So today we're going to talk about SI units, or standard units for us. These are the common prefixes that we're going to use in chemistry. A way to help you remember this is kind of a mnemonic device. It's my killer dog bit dad 'cause mom made nasty pasta. Okay, so if you notice here we have symbols for mega, kilo, and deca. They are all capital letters, and then below that they're all lowercase. So you'll notice there's a lot of M's. So we have mega, which is a capital M, milli, which is a lowercase m, and then we have micro. Micro uses the letter mu. It's a Greek letter. The easiest way to write a mu, I think, is writing a U and then adding a line in front. If you're really good at writing mu's, you can do it in one swoop. The big thing here is you want to make sure your mu does not look like an M. You want to make sure they look different so that you can tell them apart. A few other things, pico, there are prefixes that go below this and above this, but this is what's common for us to use. And also what helps me is that nano also has a -9 in the meaning of it, so they both start with the letter N, so it's another way that I can kind of help remember the prefixes. You won't have this prefix table on a quiz or on a test. You would be responsible for knowing it. And some of them we'll use more commonly than others as the year progresses. But for right now, we need to know the table in its entirety. Okay, so our steps for an SI conversion, we're going to be using, it has a bunch of names. It can be called sometimes dimensional analysis, or sometimes it can be called the factor label method or the T-tables. But the gist of it is we're going to be using tables to help us to put in key information to convert the units in a clear way. So the first thing we're going to do is we're going to write down the starting measurement. So in this first example, we have 63,200 centiliters. So I'm going to write that in. Centa has a lowercase c, but liters has a capital L. So that's step one. The next step, we're going to put the units of the starting measurement in the denominator to cancel. So we're going to put centiliters in this case in the denominator. That way, both of these units will cancel out. So the next step, we want to put the units that we want on the top. So in this problem, we want microliters, and we're going to write our very first mu, and then liters next to it. The next step's kind of a key step. What we want to do is we want to put a 1 with the larger unit. So if you can mentally think of the units that you have, which one is larger, or you can refer back to the table. In this case, we're comparing centiliters and microliters. Centiliters is larger, so centiliters will get 1. But then what we need to do is we need to figure out how many microliters will make up 1 centiliter. So that's not a number that you probably know off the top of your head. So what you want to do is you want to determine the relationship between the two units that you've memorized on the prefix chart by looking at the difference between them. So on my chart, I have centi and micro marked for us. The easiest way for me to find the difference is to take the bigger unit, which in this case is centi, which has an exponent of -2. So take that -2 exponent and subtract the second item's exponent. In this case is -6. So -2, it really turns into -2 plus 6, which results in 4. So the difference between these two values is 1 times 10 to the 4th. So what we were doing is we were using the exponents to help us to figure out what was happening. So we're going to write in 1 times 10 to the 4th. It is a positive value. When it's set up such as this, we want to make sure that we're keeping a positive value in the smaller unit. So with this method, anything that's in the top of your fraction or the numerator, you're going to multiply together. Anything in the denominator, you would divide by. In this problem, we're dividing by 1, which has no mathematical implication. So we're only going to take our original number and multiply it by the number of microliters in a centiliter in this problem. So we're going to plug this into our calculator. I'm going to show you how to do it on this TI-84 simulator, just to use the tool properly. So we'll plug in our value, 63,200 centiliters, and in this case we're multiplying by 1 times 10 to the 4th. So there's a couple of different ways you can put this in. The way that I usually use that requires the least number of buttons is starting off with 1, second E. So this second E, or second comma button, which brings up this capital E, this represents the times 10 with the little caret to whatever exponent you want. So we have 1 times 10 to the 4th, so all I have to do is 1e4, and then I can solve, and it'll give me my answer. The other option for you is doing the same thing, but using 1 times 10 to the 4th. You can do this, but notice how I put it in parentheses. It's a good habit to get into parentheses. When you multiply, it doesn't make as big of a difference. It's more for dividing, but it'll give you the same answer. In either situation, notice you get a really large number. It's not practical to write this number out in standard form. We're going to want to put this into scientific notation. Okay, so we plugged in, we got 632 million. We're going to put that into scientific notation to make it more manageable. So it'll end up being 6.32 times 10 to the 8th microliters. So in this problem, we have 89.3 kilometers. Going to start off by writing that in the starting point. So kilometers will go on the bottom because we want it to cancel out. So in this problem, we're going from kilometers, and our new unit that we want is nanometers. So after we have our problem set up, we need to figure out which one is the larger unit. The larger unit is kilometers, so we put the 1 with that. And then what we're going to do, we're going to take a look at our chart. We're going to go in between kilometers and nanometers. So for this, we're going to take the exponents. We're going to take 3 minus a negative 9, which will give us 12. So the difference here is 1 times 10 to the 12th. So that will go with nanometers here, 1 times 10 to the 12th. And then we can plug this into our calculator and solve. So in the next example, we have picograms going to milligrams. So we have 5.32 times 10 to the 8th picograms. Kind of ran out of room there. So picograms will go in the denominator. Milligrams is the unit that I want, so milligrams will go on top. Now for us, picograms is the smallest prefix that we can have, so that makes milligrams larger. So milligrams gets the 1. And we now need to figure out how many picograms are in a milligram. Using our chart, we're going to go from pico to milli. So we're going to take negative 3 minus negative 12, which will give us positive 9. So our exponent is going to be 10 to the 9th. So we can fill that in on our chart. 1 times 10 to the 9th. We can now plug into our calculator. So this is a good practice problem for plugging into your calculator to make sure you get the correct answer. Your answer should be less than 1, but not so small that you would have to put in scientific notation. So let's try it. So So you should end up with 0.532 milligrams here. Let me walk you through how I got that in my calculator. So we're going to take 5.32 second, comma, 8 divided by 1E9, which gives me 0.532. The thing of this problem, the reason why we're dividing is because our number is in the denominator. Anytime you have the number on the bottom, you're dividing. Anytime you have the number on top, you're multiplying. So here's the work for the third example. Hopefully you tried it on your own.